Anyway, like I said, we got some fun stuff to get into today, so I can't wait. I'm gonna get to it. I want to get to it. Let's go to our grade screen as usual. We scroll down, we see last week we should have just turned in the test. All we got left is module 4 now. And we don't have much time. Look at this. We got this week, we got 2 lessons. And then we have a week off for Thanksgiving. And then we've only got 2 weeks of lessons when we get back. We have 2 weeks, and then we have finals on the 3rd week. And the final for this class, I believe, is on Wednesday at 12 o'clock. I think our final starts exactly at noon on Wednesday of finals week. But we'll learn more about that as we get closer. But that is coming up in just a very, very short amount of time. We've only got 4 weeks of class left, and the last one of those is actually finals week. So we don't have a whole lot. So look at this. We're going to get into polynomial long division. I'm excited. And talk about theorems of algebra that kind of go along with that and that we're going to use. So let's go get module 4 going. Hopefully everyone's got their test turned in. I still got tests to grade. I saw several people have it turned in, and I haven't graded it yet, but I will get to it. If I don't get it all graded this week, I'll have to do it over Thanksgiving. I don't want to have to do that. Okay, module 2 should be closed. Module 3 is opening module 4. And we'll look at these first 2 lessons. So let's look at polynomial long division. You probably haven't done long division since grade school. Well, maybe you did some in middle school. I don't know. But an old skill that we're going to revive. Polynomials in the real world. So a cantilever is a beam that's anchored only at one end that can still bear the weight of some force. Like these cranes, it's a cantilever. There's a great big weight down here on this short end. And so it can balance out and hold a lot of weight on the long end. So these beams are used in a variety of applications, from bridges to airplanes to micro electromechanical systems. Impressed I could say that. Micro electromechanical. Use that one in Scrabble. You get a lot of points. The amount of bending a cantilever undergoes a 3rd degree polynomial function of the cantilever's length. So there's a lot of algebra involved in operating a crane and figuring out how much the weight it can hold and all that kind of stuff. And there's many real world situations can be modeled using polynomial functions. That's why it's important to know how to use them. So one key feature is when these functions equal 0, right? With quadratics, with linear, with any polynomial function, this makes it easy to construct a rough graph and know how the function is going to behave. So we are going to figure out how long division can be used to find the factors of a polynomial function. All right, let's have a little review on long division. What are they using here in their sample? Quotient dividend. All right. The names. When we set up a division problem, the number outside that you're dividing with is the divisor. The number that's you're dividing into is the dividend. And what it leaves us is the quotient. So let's do a sample, get our notes started with just a refresher on long division. All right, so long division. And let's divide something like the number 8 into, how about 1,323? Some crazy number, right? So if you remember how long division works, we have this 8. And we said 8 won't go into 1, so we have to use the second digit, 13. I guess that would be a comma, but 8 goes into 13, and we put it over the farthest right digit that we're using, right? So it goes in there one time, and then we have to multiply it back. Right? So we multiply 1 times 8 and put it under the 13, and then we subtract, and that leaves us 5. Then we bring the next digit down. Then we say, how many times does 8 go into 52? And we put that number over the 2 because that's the farthest right digit. So 6 times 8 is 48. We subtract 52 minus 48 is 4. And then we bring down the next digit. Now, how many times does 8 go into 43? We put that over the 3. 5 times 8 is 40. We subtract, and we have a remainder of 3. So 1323 divided by 8 is 165 and 3/8. Because that was our remainder, 3/8. So this tells us right off that 1323 is not evenly divided by 8 because we had a remainder. So 8 is not a factor. If we were taking the factors of 1323, what numbers multiply together to get 1323? And who knows, it might even be a prime number. I just picked it out of the air. But if it's not a prime number, what factors? We know 8 is not one of the factors. 8 will not go into that because when we divide by 8, we get a remainder. 8 is not a factor of 1323. So that's just a refresher on how long division works, since it's been a few years since you were in grade school and had to do that back then. So let's look back here. All right. They use 13 and 158. And they end up with a remainder of 2. It goes in 12. So it's 12 and 2/13. So if you need to go through that lesson, go right ahead. So the steps to divide polynomials are exactly the same as the steps when dividing integers. To help you remember the steps, try to follow in phase. Discovering math solutions bring rewards. Means division, multiplication, subtraction, bring down the next number, and repeat. So let's take a look at dividing a polynomial by a monomial. So they're going to give us a monomial is just a one term, like 2x. 2x is a monomial. And we're going to divide it into 2x to the third minus 10x squared plus 18x. So let's check this video out.
Before you can start with the division process, you need to set up the problem. The dividend is the trinomial 2x cubed minus 10x squared plus 18x. And the divisor is the monomial 2x. Remember, the steps in the division process are divide, multiply, subtract, bring down, and repeat. First, divide. How many times will 2x divide into 2x cubed? You can think of this as dividing 2x cubed by 2x. 2 divided by 2 is 1. But what is x cubed divided by x? When you multiply variables, the exponents are added. When you divide variables, the exponents are subtracted. So 2x cubed divided by 2x is 1x squared, or just x squared. This gives you the first term in the quotient. Next is multiplication. Multiply x squared by 2x. The product is placed underneath the first term of the dividend. Then it's time for subtraction. Subtract 2x cubed from 2x cubed. Now bring down the next term. Remove the 0 since adding or subtracting a term from 0 doesn't change the value of the term. Repeat the steps of long division until all the terms of the dividend have been exhausted. Time to divide again. Divide negative 10x squared by 2x. You can think of it this way. Negative 10 divided by 2 is negative 5. But what is x squared divided by x? Subtract the exponents. So negative 10x squared divided by 2x is negative 5x to the first power, or just negative 5x. Place this above the second term of the dividend. Multiply. Negative 5x times 2x is negative 10x squared. Subtract. Negative 10x squared minus negative 10x squared is 0x squared. Bring down the next term. Again, you can remove 0x squared since it just has a value of 0. Repeat the process. Time to divide again. Divide 18x by 2x. You can think of it this way. 18 divided by 2 is 9. What is x divided by x? Think about it. What is 11 divided by 11 or 100 divided by 100? The answer to all these questions is 1. Any number or variable divided by itself will result in 1. Another way to look at it is through the subtraction of exponents. Any number or term raised to the power of 0 equals 1. So 18x divided by 2x is 9. Place this above the third term of the dividend. 9 times 2x is 18x. 18x minus 18x is 0x. There are no more terms to bring down. Therefore, the quotient has been found. The answer is x squared minus 5x plus 9. Check your work by multiplying the quotient by the divisor. This product is the same as the dividend, so the quotient x squared minus 5x plus 9 is accurate.
So notice the remainder is 0. So 2x is actually one of the factors of this polynomial. So if we were writing the factors, it's 2x and then x squared minus 5x plus 9. Now we haven't explored, maybe that factors as well, x squared minus 5x plus 9, or it might not factor into nice numbers. It might be irrational. You know, we could solve that quadratic. But we know one of the factors of the 2x third polynomial is 2x. So that was the video we just watched there on dividing it by a monomial, just one term. And then here's another example if you need another. We're going to move on to dividing by like binomials and stuff. But here's another example where they divide 12x squared minus 27x by negative 3x. And they go through all the steps right there. So I won't go through that one because you have that right there on page 1 if you need to look at that. So, all right, let's go to page 2. Polynomial division of a polynomial by a polynomial. All right, they have a video just for the first. We're going to do this one on paper instead of going through their video because you have their video you can watch anytime. So I'm going to set this up. It's been a month or so since I've done any polynomial long division, but this is fun. All right, since there's two terms, we have an x minus 6. We have to look at the first two terms of the quotient of the dividend, pardon me, the divisor, dividend, quotients up here. So we have to look at the first two terms. Now, all we have to really pay attention to, though, to figure out dividing this by this is the first term, x squared divided by x. So how many times does x squared, when we divide x, does it go into it? And we're going to put the answer under the second term. Since we're using two terms, we're putting it. So x times x is x squared. X times negative 6 is negative 6x. All right, so x minus 6 goes into x squared minus 2x, x times. Because we're just looking at the first terms, x squared divided by x. X squared divided by x, x times. Now we multiply, we get x squared minus 6x. Now here's the thing, we're subtracting all of that. We're subtracting it. So this is where you have to be careful. This cancels out, right? X squared minus x squared. But this is negative 2x minus negative 6x. Negative 2x minus negative 6x. So this is a positive 4x. Because we subtracted a negative. That's where you got to pay attention. It's easy to mess it up if you don't pay attention that we're subtracting a negative. Then we're going to bring this down because we just bring down the next term. Now, how many times does x go into 4x? Well, that would be plus 4. Then we're going to multiply. 4 times x is 4x. 4 times negative 6, negative 24. Again, we're subtracting the binomial. 4x minus 4x cancels out. 4 minus negative 24 is 28. This is our remainder. This is the remainder. So this is not a factor. This is a quadratic equation. If we were to factor it, this is not one of the factors because we have a remainder. So when you divide this by this, the answer is x plus 4 plus 28x minus 6's. That's what it equals. X plus 4 plus 28x minus 6's, because that was the remainder we got when we divided by x minus 6. Let's see what their video shows here. I'm going to just fast forward to the end. There it is, x plus 4 plus 28x minus 6's. So they did. If you want to go through that video and see it done again, there it is. But x plus 4 plus 28x minus 6's is what you'll end up with. That's example number 1. Let's take a look at more examples. So here's, let's see. They go through the 5 steps there. Oh yeah, this is a good one for us to have in our notes. Very good example to have in our notes right here. So this is what f of x equals, 9x squared plus 6. This is what g of x equals, 3x minus 1. And they want us to divide f of x by g of x. So g of x is outside 3x minus 1. And here's where it gets tricky. 9x squared. If we're going to divide, we have to use the full equation. You're like, what do you mean, the full equation? Well, this is the x squared. How many x's do we have? Because, like this one, we had 1x squared, negative 2x's, and a constant of 4. We have 0 x's, but we have to account for that in our problem. So we have to write it like this. 9x squared plus 0x plus 6. Because if we don't do that, we're going to have a problem when we try to divide. Very, very important. And I'm going to underline it in red. Plus 0x. Okay, so we're dividing this binomial. So we're going to take the first 2 terms. And we're going to divide 9x squared divided by 3. 9x squared divided by 3x. 9x squared divided by 3x. So this would equal 3x, right? 9 divided by 3 is 3. X squared divided by x is x. So this goes in 3x amount of times. And we write it over the x term. This is an x. We put it over the x term. Multiply. 3x times 3x is 9x squared. 3x times negative 1 is minus 3x. And we're going to subtract that. 9x squared minus 9x squared, that cancels out. 0x minus 3 minus negative 3 is just 3x. 0x minus negative 3x is a positive 3x. Bring down the next term. How many times does 3x go into 3x? 1 time. So multiply 1. 3x minus 1. Subtract 3x minus 3x. 6 minus negative 1. So when you divide 9x squared plus 6 by 3x minus 1, your answer is 3x plus 1 plus 7 3x minus 1s. That's what this equals when you divide f of x by g of x. 3x plus 1 plus 7, 3x minus 1s. Let's go through their steps and see if they get the same answer. Okay, look, they set it up the same way. You got to have that 0x in there. So 9x squared divided by 3x is 3x. And you multiply that, 9x squared minus 3x. When you subtract, you're subtracting a negative, which means you're adding it. Bring down the next term and repeat. So the answer is 3x plus 1 plus 7, 3x minus 1. That's the exact same answer we had. So what would happen if you didn't put the 0x? You'd have just got 3x. But the problem is 3x and the 6 cannot be subtracted from one another. You can't subtract 3x from 6 because you left out the 0x term. All right, take a look at the quotients in examples 1 and 2. The division resulted in a remainder. This indicates that the divisor in each example is not a factor. If it was a factor, the remainder would be 0. So we're going to hit that point a few more times in the next lesson. All right, let's apply polynomial long division. So the volume of this box, we could say is x to the third plus 4x squared minus 31x minus 7. The length of the box is x plus 7, and the width is x minus 5. How tall is it? Oh, that's a good question. I'm going to go on the back. So volume equals length times width times height. So that's what the volume equals, the length times the width times the height. And if we want to know the height, because that's what the question we don't know the height. If we divide by the length and the width on both sides, height equals the volume divided by the length times the width. And it doesn't want to focus on that. There we go. So that's what the height equals. And let's see what were all of these equations. So the volume was x to the third plus 4x squared minus 31x minus 70. And we have x plus 7 and x minus 5 as the two dimensions we know. Okay, so this is the length and the width. And this is the volume. So let's set this problem up. We're going to divide the volume, x to the third plus 4x squared minus 31x minus 70. And we're going to divide that by x plus 7 times x minus 5. And we can figure out what the height is. So the first thing we can do is let's go ahead and combine these. Let's do that multiplication, which we can do simply by distributing. X times x is x squared. X times negative 5 is negative 5x. Now distribute the 7. 7 times x is 7x. 7 times negative 5 is negative 35. Like terms. So it equals x squared plus 2x minus 35. Okay, so that's what this equals right there. So if we want to divide this by this, or divide this by this, actually, we could set it up this way. X squared plus 2x minus 35 divided into x to the third plus 4x squared minus 31x minus 70. Since we have 3 terms, we need to use the first 3 terms here. All we need to look at is the first term to divide. How many times, what do we get when we x to the third divided by x squared? Well, that's just x, and we're going to put it over here above the x term, the farthest right term that we're using. Okay, so that's how many times x squared divides into x to the third, x number of times. Now let's multiply. X times x squared is x to the third. x times 2x is 2x squared. X times negative 35 is negative 35x. Now we need to subtract this. X to the third minus x to the third. That's 0. 4x squared minus 2x squared. So that's 2x squared. Negative 35, I'm sorry, negative 31x minus negative 35. Minus a negative. So that's really adding. Negative 31 plus is plus 4x. And then we bring down the next term. Okay. How many times does x squared go into 2x squared? Just 2 times. So we got a plus 2 that goes over the constant. 2 times x squared is 2x squared. 2 times 2x is 4x. 2 times negative 35 is negative 70. And we subtract that. Look, it's the exact same equation. 2x squared plus 4x minus 70 minus 2x squared plus 4x minus 70. The remainder is 0. So the height is x plus 2 because there's no remainder. So the 3 factors, that's pretty nice. The factors of x to the third plus 4x squared minus 31x minus 70 is x plus 2 times x plus 7 times x minus 5. That means we could actually draw a graph of that because we know the zeros. If we were going to graph this, just as an aside, just as a thought, what if I wanted to graph that? So if I have a graph, we know this is an x to the third, right? So x to the third with a positive coefficient goes up on the right and down on the left. We've learned that in the past. If x plus 2 is one of the zeros, that means x equals negative 2. So 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So we know if x plus 2 is one of the factors, this is one of the places it crosses the x-axis at negative 2. And also x plus 7, 1, 2, 3, 4, 5. So this is also one of the places it crosses the x-axis. X minus 5, 1, 2, 3, 4, 5. There are the 3 zeros because we found the 3 factors. Look, the original equation says x to the third plus 4x squared minus 31x minus 70. Minus 70 way down here is, say that's a negative 7. That's going to be where it crosses the y-axis. That's the y-intercept at negative 70. So now we can make a sketch of the graph. It's not an exact graph because we don't know how high this goes, but we know that it goes down on the left, it comes up through there, it comes down here, it goes all the way down to negative 70, where it turns around and comes back up. Look, we can just sketch a graph. Negative 70, this is really going to dip down a lot farther to get to negative 70 the way I drew this. But this is just a sketch, not an exact graph, but it's a sketch of x to the third plus 4x squared minus 31x minus 70. Because we found the 3 factors, which gives us the 3 zeros. And we know negative 70 is the y-intercept because that's when x equals 0. So if x equals 0, all these terms are 0. Kind of nice. By long division, we were able to solve it for one thing, to get the 3 zeros, and actually could make a sketch of it. Long division with polynomials. That's crazy, Mr. Brock. Ah, yes. So let's see. And so they wanted us to find what was the height. x plus 2. That's what we got. Divide the numerator and following steps, polynomial division. We found the height using polynomial division. And then they show you how to get that. Dividing that into that, working your steps through, x plus 2 is the answer. And here's another example, if you need another example on polynomials, divided by polynomials, using x plus 7 and dividing it into this quadratic equation. Go through all the steps there. And let's see. So, see what they get as their answer there. It has a remainder of 0. So it's x plus 7 and 4x minus 1 is the two factors. When you multiply it back together, you get it back. So that's the two factors. All right, let's look at the lesson summary. We've got another lesson to go through. Steps to dividing polynomials. It's the same steps you learned in grade school. Divide, multiply, subtract, bring down, repeat. Here's the important part. If you have missing terms, you have to add them. X to the fourth minus 1 is x to the fourth plus 0x to the third plus 0x squared plus 0x minus 1. Anytime you're missing that, in either the dividend or the divisor, you have to add those zeros. You have to account for every term. If it's missing, it's a 0 coefficient. And if the quotient has no remainder, it's a factor of the dividend. All right, they do give you some practice problems to look at. Divide, select your choice, and see if you're right. Divide 5x squared minus 60x plus 35 by 5. Well, that's easy. You just factored out a 5 there. So it's x squared minus 12x plus 7. Correct, but there's 3 problems there. This one you're dividing by 7x. That's a little tougher. And then there's another one. You try 2. Divide x to the third plus 6x squared minus 5x plus 14 by x plus 7. And it got your work right there. There's 3 problems here. Oh, this one is missing a term. It's missing the constant. Look, it's got x to the third plus minus 8x squared minus 13x plus 0. You're missing that plus 0, but may not be. Oh, no, there it is, plus 16. I didn't see it. Plus 16. It's not missing the 0. And, oh, here's one that's missing the x term, 72x squared minus 7. You have to add that 0x. All right, what's over here? Oh, that was, you tried to? Okay. What's on page 5? More practice. Match each one to its answer. If you divide 40x squared plus 8x plus 20 and divide it by 4, which one do you get? You just drag it to the answer. The answer is 10x squared plus 2x plus 5. If you divide this by 6x, drag it to its answer. All right. So there's 6 problems for you to do right there. And then there's 2 more pages because this is page 1 of 3. So plenty of practice. Let's look at the assignment for this lesson. Divide this by 7x. Divide this by 8x squared. Divide this by x minus 4. Divide by 2x plus 5. And then it gives you one of those volume problems where here's what the whole volume is. Here's the length. Here's the height. What's the width? Works the same way. Multiply these 2 binomials together and then divide it into the cubic equation. All right, let's look at the second lesson, theorems, because the theorems are going to help put things together here. So most people, even if you're not mathematically minded, have heard of the Pythagorean theorem. You can talk about people in the street and say, have you heard the Pythagorean theorem? They'll go, yeah. And some of them can even tell you how it works. A lot of them go, oh, I don't remember what it is, but I remember it. Yeah, it's a squared plus b squared equals c squared. Right? It says the sum of the squares of the 2 sides of a right triangle is equal to the square of the hypotenuse. That's the technical terms. But what is a theorem? A theorem is a statement, not necessarily mathematical, but often is, proven by experimentation. So we're going to discover 3 very important theorems to help us work with polynomials. So what key features of a polynomial can be found using the fundamental theorem of algebra and the factor theorem? And then how's the remainder theorem allow for zeros to be identified? The fundamental theorem of algebra. Okay, and they're kind of mixing it in with the discriminant that we've talked about a lot. So the solutions to quadratic equations can be found by applying the quadratic formula or by completing the square, or you can factor it or graph it sometimes. If the value of the discriminant, b squared minus 4ac, is a perfect square, which we've talked about quite a bit in here, then the quadratic equation can be factored if that's a perfect square. Like x squared plus 11x plus 18, if we calculate the discriminant, it equals 49, which is a perfect square. It's 7 times 7. So since it's a perfect square, this is factorable. And then when you graph it, it looks like this. -9 and -2 are where the zeros are. So that tells you the factors are x plus 9 times x plus 2. That's the 2 factors of the equation. So pay attention where this function crosses the x-axis. These x-intercepts are the real number solutions when the quadratic equation is set to equal 0. That's why they're called the zeros of the function. So there are 2 zeros. 2 zeros. Look at this cubic function, x to the third minus 12x squared plus 35x. When you graph it, look, there's 3 zeros. There's one at 0, there's one at 5, there's one at 7. And it's a cubic function. Interesting. So let's determine the zeros of this, x squared minus 3x minus 28. How long is this video? 2.5 minutes. All right, we'll take 2.5 minutes for that. We have time.
The degree of the polynomial function is 2. So the fundamental theorem of algebra indicates that the function has 2 zeros. The zeros of the function are the values of x, which make the function equal to 0. So, replace the function notation f of x with 0 to begin solving for x. To find the zeros of this function, first verify that x squared minus 3x minus 28 can be factored, using the discriminant b squared minus 4ac. The discriminant is 121, which is a perfect square. So, x squared minus 3x minus 28 can be factored. The 3 terms have no common factor, so factor into 2 binomials. Now, find the factors of the last term, negative 28, that sum to the middle coefficient of negative 3. The factors of 4 and negative 7 satisfy both conditions. So, those are the numbers that fit into the second position of each binomial factor. The zero product property states that for these factors to result in a product of 0, one or both of them must equal 0. Therefore, the zeros of f of x equals x squared minus 3x minus 28 are x equals negative 4 and x equals 7. The x-intercepts of the graph of the function confirm these zeros.
Okay, so that was factoring to find the 2 zeros. Again, it's going to make me reload the page because it doesn't want to get out of full screen mode. But that kind of opens the discussion to the fundamental theorem of algebra. Fundamental theorem of algebra. There's a second example there, but we're not going to, well, I'm going to do something like that on paper. Find the zeros of this function. Okay, so let's talk about the fundamental theorem of algebra. The fundamental theorem of algebra tells us how many zeros a polynomial has. And the way it works, I'll just underline that fundamental theorem of algebra. The fundamental theorem of algebra says the degree of the polynomial equals the number of zeros. The degree of the polynomial equals the number of zeros. That's the number of solutions. Now, be aware that some of those zeros may be imaginary zeros. They may be complex zeros, but they're still zeros. So how many zeros, which is another word for solutions, how many solutions does a quadratic equation have? X squared minus 4x plus 5. That's pretty simple. I'm going to let you put that in the chat so you can participate here. How many zeros does a quadratic equation have? X squared minus 4x plus 5. The first one's a gimme, guys. Yeah. Right. We know there's two. We know there's two. Yeah. Good job. You guys are getting that. There are two zeros. But the fundamental theorem of algebra tells us that because that is the highest exponent. It says that's the highest exponent. That's the degree of the polynomial. Whatever the highest exponent is the degree. So it said, yeah, of course there's two because it's x squared. What about this one? 3x. I'm just going to do this one at a time here. So 3x to the fifth minus 4x to the fourth minus x minus 2. How many zeros should we expect to be able to find? Even if they're imaginary. They may be imaginary. What is the degree of that polynomial? In other words, what's the largest exponent? Yeah, this has 5 zeros according to the fundamental theorem of algebra. There are 5 answers. How about this one? 19x to the 9th minus 3x to the 8th plus 2x to the 6th minus 4x minus 1. How many zeros? Just look for the biggest exponent. Now, I don't want to have to solve that. That's going to take a lot of work to figure them out. And I certainly don't want to solve this one. How many zeros does that have? It's got 47. Yeah, the biggest exponent is 47. It doesn't matter how large the polynomial is. The fundamental theorem of algebra is very, very simple. Don't mess that up. It's very, very simple. Whatever the largest exponent is the number of zeros it has. Some of them may be imaginary. If we graph that, I bet it doesn't cross the x-axis 47 times. But now I'm dying to do it. Okay, we're going to graph that just because I'm dying to see it. But we're going to put it x to the 47th minus 11x to the 31st plus 2x to the 4th plus x. Okay, it mainly hangs around this area. And it looks like there are 5 zeros. There's 5 real zeros. The other 42 are imaginary. Now, if we change the equation and add more of these in there, plus 6x to the 39th, you know, it'll change the shape of it. And if we add enough terms, we might create more real zeros. But there, we still just have 5, even though we added another term. So a lot of these are imaginary zeros in this problem. But that's how that works. That's how that works. Even though some of them are imaginary, that is how many zeros fundamental theorem about. So this is very simple. Do not make this hard. This is that easy. It looks that easy. It is that easy. There's no trick questions here. All right. Now, the other example they were giving us is find the zeros of this. F of x equals, and I'm going to make it up, x minus 2, x plus 1, x minus 5, x plus 6. And it wants us to find the zeros. How many zeros would we expect there to be? It's like, wait a minute, this is just x to the first. Well, that's true, but we're multiplying it times other x's. So if we multiply all these four terms together, what's the fundamental theorem of algebra say? How many solutions is it going to have? Yeah, if we multiply all these together, we'll have an x times an x times an x times an x. We'll have some kind of x to the fourth, dot, 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 whatever the equation is. But the biggest exponent is going to be x to the fourth because we have four x's that we're multiplying in there. So we expect 4 zeros. 4 zeros. There are 4 zeros for this. I'm using the British spelling of zeros today. Some days I don't. Some days I don't put the E. But, I'm feeling British today. So what are the 4 zeros of this equation? It's like, do we need to graph that? No, to find the zeros, you just set it equal to 0. If we want to find the zeros of any equation, we set it equal to 0. And if this equation equals 0, that means at least one of these equals 0. Something's got to equal 0 for us to end up with a 0. So x minus 2 equals 0, or x plus 1 equals 0, x minus 5 equals 0, x plus 6 equals 0. So add 2. Here's one of the zeros, x equals 2. Does that surprise you? It shouldn't. X minus 2 is one of the factors. So if x minus 2 is a factor, x equals 2. Subtract 1 from both sides. Oh, look, x equals negative 1. That's one of the other factors. X plus 1 gives us this 0. Add 5 to both sides. X equals 5 is another 0 from x minus 5. And x plus 6 gives us x equals negative 6. This one is really that simple too. Don't overcomplicate it. Don't overthink that. When you see a problem like that and says, name the zeros of this equation, it's that simple. X minus 2, it's 2. X plus 1, it's negative 1. X minus 5, it's 5. X plus 6, it's negative 6. It is that simple. Do not overcomplicate that in your head. Do not overthink that. So these two things are both fairly simple. All right, so let's go back to their problem. So they're finding the zeros of x plus 2, x plus 2, x minus 1, and x minus 3. That's a little trickier because look, you've got the same thing twice, x plus 2, x plus 2. That just means negative 2 is a solution and it appears twice. Negative 2, 1, and 3. And you can watch that video if you want to see him go through that. And it's not even going to tell me how long it is. There's more on the fundamental theorem of algebra. But again, it's that simple. If we had x minus 13, x minus 18, and x plus 9, that's a third degree. There are 3 x's being multiplied together. So there are 3 solutions. And they are 13, 18, and negative 9. 13, 18, negative 9. All right, let's go to page 2. That was all on page 1. The factor theorem. So you did a great job with the fundamental theorem of algebra, but unfortunately, not all polynomials will be in factored form. So let's look at the factor theorem. And they want us to start by dividing x squared plus 11x plus 18 divided by x plus 2. All right, let me get a clean sheet of paper, and we will do that. So, 2 terms. So we're looking at the first 2 terms here. X squared plus 11x. How many times does x go into x squared? X times. X times x is x squared. X times 2 is 2x. Subtract. X squared minus x squared. 11x minus 2x. 9x. Bring down the 18. How many times does x go into 9x? 9 times. 9 times x is 9x. 9 times 2 is 18. When we subtract that, it's 0. So the factor theorem says when you divide polynomials, if the remainder is 0, the divisor is a factor of the dividend. So it's basically saying x squared plus 11x plus 18. We divided by x plus 2 and got a remainder of 0. So x plus 2 is one of the factors. And we know the other factor is what's left when we divide that out. So we know the factors of this quadratic equation because the remainder was 0. Yes, the factor theorem is that simple. Don't overthink the factor theorem. If you divide something, one polynomial into another one, and the remainder is 0, this is a factor of that. And so is that, because there's no remainder. So that's another factor. Is a factor.
Mason, nice, sir.
Is a factor.
Nice, Austin. Nice, Maddox.
Factor theorem. Thank you, factor theorem. So when we divide there, we got x plus 9. If we would have divided by x plus 9, we would end up with x plus 2 with no remainder, because both of those are the factors. All right, so now it wants to know, is x plus 12 a factor of x squared plus 6x minus 72?
Hey, girl.
Well, let's go through the steps. There's the two problems. We set it up, x plus 12 divided into x squared plus 6x minus 72. And then if you do the math, you end up with x minus 6 and a remainder of 0. Yes, x plus 12 is a factor of x squared plus 6x minus 72. And the other factor is x minus 6. We just factored that quadratic by dividing a guess in there. X plus 12. Let's see if that's a factor. Yay! Learn more on the factor theorem. What more could there to be to learn? Is x minus 2 a factor of negative 3x to the third plus 11x squared minus 8? So they had to put that 0x in there. And when they did all of them work, we ended up with a remainder of 12. So no, that is not a factor because it's not 0. X minus 2 is not a factor of this function. Quite simply that. Another example is x minus 7, a factor of x to the third minus 49x plus 6. No, because the remainder was 6 when they got finished. Not a factor. Okay, so there's two theorems we've learned. We've learned the fundamental theorem of algebra and the factor theorem. Now let's talk about the remainder theorem. When a function is in factored form, the zeros can be found by setting each one equal to 0 and solving. Right. So the fundamental theorem of algebra tells us the number of zeros of the functions equal to the degree of the function. So we know that x squared plus 11x plus 18 has two solutions because it's x squared. We found the factors on the previous page, x plus 2 and x plus 9. We can find the zeros by setting x plus 2 equal to 0, and you get negative 2. X plus 9 equals 0, you get negative 9. So those are the two zeros of the function. And if the function is divided by one of those factors, The factor theorem that we just looked at says the remainder will be 0. Remainder of 0. Either one, x plus 2 and x plus 9, dividing by either one will give us a remainder of 0. And what happens, oh, this is pretty cool. What happens when we substitute these zeros into the equation? Oh, I want to find that. So the zeros were x equals -2, x equals -9. Right? That's the two solutions. So what happens if we take this f of x and I'm going to box that out. And we're going to take the solutions. We're going to start with -2 and say, what about when we substitute that in there? So x squared becomes -2 squared. 11x becomes 11 times -2. 18 is at the end. So x squared plus 11x plus 18 becomes -2 squared plus 11 times -2 plus 18 using the solution that we found. Okay. -2 squared. So that's -2 times -2. +4. 11 times -2. -22 plus 18. 4 minus 22 is -18 plus 18. Wait a minute. When we substitute that in there, we get 0. What about the other solution? Let's do 9. Sorry, -9. -9 squared
You pick which one.
plus 11 times -9 plus 18. Okay, I'm taking the other solution. I'm substituting it into the equation. -9 times -9 is a positive 81. 11 times -9 is -99 plus 18. Well, what's 81 plus 18? 81 plus 18 is 99. Minus 99, this equals 0 as well. I think we're onto something. So let's find out. You substitute -2 in, you get 0. When we substitute -9 in, we get 0. So that's interesting. When a polynomial is divided by a binomial factor, the remainder is 0. And when we substitute the 0 back in, we'll get 0 for the result of the function. What happens when a polynomial is divided by a nomial that's not a factor? So let's go to this one where they divided x plus 1. Now this is the same quadratic we had. So we know the factors are x plus 2 and x plus 9, right? So let's try a different one. Okay, what if I divided by x plus 1? So x goes into x squared x times. You multiply x squared plus 1x, subtract that, 10x plus 18. X goes into that 10 times, 10x plus 10, remainder of 8. Okay, that has a remainder of 8. What happens if I substitute -1 in there? Because if it's x plus 1, -1 would have been a 0. -1 squared plus 11 times -1 plus 18, 1 plus -11 plus 18. It equals 8. That's the exact same thing that the remainder equaled when we divided by that binomial. So when the opposite of the constant term of the binomial is substituted into x, the result's equal to the remainder. This is the remainder theorem. Wow. Let's try that with one of these that we've already done. Let's see. Okay, we had this one. We had x squared minus 2x plus 4, and we divided x minus 6 in it. Right? So see, x minus 6 equals 0. So x would equal 6, right? Let's substitute 6 into this equation. So I'll do it right up here. 6 squared minus 2 times 6 plus 4. 6 squared minus 2 times 6 plus 4. 36 minus 12 plus 4. 36 minus 12 is 24. Wait a minute. Look at there.
So down at the bottom, you have to figure out. So
I'll be doggone.
so replace that with a P. You might have to write it out. Wherever you see,
This is the remainder theorem.
see if that helps. You get 2 word maybe.
Remainder theorem says we can substitute in the same, well, you have to set this equal to 0. If it's x minus 6, it would be 6 because we set equal to 0. 6 minus 6 equals 0. If we take the opposite of whatever this number is and substitute it into the equation, that will tell us what the remainder is if we divide it. That is so cool. Let's try that again. We got this one down here. This one was 9x squared plus 6. Oh, is this going to work? Because this is a 3x minus 1. Let's see. 3x minus 1 equals 0. So 3x equals 1. X equals, oh, I have to do it with a fraction, but I think we can do that. Let's do this. So if we substitute 1/3 in, since this was a 3x minus 1, x would be 1/3. 3x minus 1. 9 times 1/3 squared plus 6. Well, 1/3 squared is 1/3 times 1/3. When you multiply fractions, you multiply straight across. 1 times 1 is 1. 3 times 3 is 9. So 1/3 squared is 1/9. 9 times 1/9 plus 6. 9 times 1/9 is just 1. Looky there. The remainder theorem is pretty cool because now we know what the remainder would be if we divided in there, because we already showed that. We did 3x minus 1 divided into this, and we know what the remainder is 7. But we find the same thing by just substituting a number into there. All right, that's pretty darn cool. The remainder theorem delivers some important facts. So given a polynomial function f of x and a number a, so that's basically if you have x minus a. So if this number a is a factor of x, then a is a 0 of the polynomial. So x minus a can be proved by using long division and showing that it has 0 as a remainder. Using factoring methods when appropriate, grouping completely square, and showing that that is a factor. And a is a 0 if the graph shows it crosses the x-axis at a. If we substitute a into x minus a will equal 0, then substitute it into the equation should equal 0 if it is a 0 of the polynomial. But if it equals 7, it'll equal 7, like the one we just did. That is pretty cool. Find the remainder when f of x of 5x squared plus 51x plus 16 is divided by x plus 10. To find the remainder, you can use one of two methods, division or substitution. Oh, well, let's do that then, since they gave us a choice. We're going to use the factor theorem. They want to know what the remainder is. That's all they ask. All right, since they gave me a choice, all they want to know is the remainder. What is the remainder? Which, if the remainder is 0, we know this is a factor of this equation. But since they gave me a choice, I'm going to use negative 10, because x plus 10 would be negative 10, and I'm going to substitute it in there. Negative 10. I'm going to use that factor, the remainder theorem. 51 times negative 10 plus 16. Let's see, negative 10 squared. Negative 10 times negative 10 is 100 times 5. 500. Plus 51 times negative 10, negative 510, plus 16. 500 minus 510 is negative 10, plus 16. Remainder is 6. Boy, that was a lot easier than doing all the division of taking x plus 10 and setting it up and dividing that into there and doing all that. 6. Let's see if we're right. in division, they came up with 6. In substitution, we come up with 6. So we could have done it by dividing like this. Or I use substitution because I think that's pretty darn cool. And it seems shorter. There's another example in the remainder theorem, but let's look at the lesson summary. What key features of polynomial can be found by using the fundamental theorem of algebra and the factor theorem? You can find out how many zeros, and the factor theorem will tell you what they are if you have a remainder of 0. How does the remainder theorem allow for zeros to be identified? By substituting in. So a theorem is a proven statement based on experimentation. So we learned 3 in this lesson: the fundamental theorem of algebra, the factor theorem, and the remainder theorem. Fundamental theorem of algebra says the degree of the polynomial is equal to the number of zeros, both real and imaginary, real and complex, of a function. So it says f of x equals x squared minus 3x minus 28. We know the fundamental theorem of algebra says it's going to have 2 zeros. We can factor it there. The zero product property tells us that for these factors result in a product of 0, one of them is going to be 0 or both of them. So x plus 4 equals negative 4. X minus 7 equals 7. When we graph it, we see those 2 zeros. So the factor theorem says if x minus 5 is divided into this and it has a remainder of 0, this is a factor. And that's another factor. The remainder theorem says we can do it this way and divide, or we can substitute it in and get the same answer. Negative 9 is a remainder. Pretty cool. All right, 2 pages of practice problems for you guys. Find the zeros of each function. So negative 2, is that a 0 of this one? Is that a 0 of this one? Or is that a 0 of this one? So you got to work all 3 of them and figure out, oh, that's that one, right? That's that one. So anyway, if you do those, it'll stay there if you're correct. All right, let's go to page 5 and look at those sample problems. Activity 1, activity 2. According to the fundamental theorem of algebra, how many zeros does this have? Well, let's see. There's an x, x squared, x third, x fourth, x fifth. The biggest one's an x to the 5th. Great job. Next. What are the zeros? So there's 8 problems right there. And then you have activity 2 has 3 more problems. And that's check my work type stuff. Is x minus 4 a factor? Well, you can either divide that or you can take the number 4 and substitute it. All right, 3 problems there. Let's look at the assignment that goes with the theorems of algebra lesson. Oh, I like the first one. According to the fundamental theorem of algebra, how many zeros does this have? Oh, no work there. All you have to do is look at it, answer the question. Which of the following is a 0 for this function? And look, it's in factored form. X minus 15 times x plus 1 times x minus 10. We don't have any work really to do there either. Is x plus 10 a factor of this function? Okay, you know how to do that. Now notice there's no x squared. You would have to put in a 0x squared if you're dividing. If you're substituting, you don't have to. Find the remainder. You can do that dividing or by substituting according to the factor of the remainder theorem. And find the remainder here. Again, the remainder theorem, you can divide or substitute. 5 problems. 5 problems. All right, we learned some cool stuff today. We can do long division with polynomials. Kind of fun, actually. Kind of fun. And we talked about the fundamental theorem of algebra. It's nice that we get halfway through Algebra 2 and finally learn what just the fundamentals of algebra are. Yeah, the fundamental theorem of algebra. And the remainder and the factor theorem. Both cool things. They all work together to help us figure out solutions or zeros of polynomials. And this helps us with polynomials that are larger than quadratics. We know lots of ways to solve quadratics, but how do we solve an x to the 3rd or an x to the 4th or an x to the 5th? Well, we can actually do it with these theorems we learned today. And polynomial division. If we think we know one, we can divide it and see, does it have a remainder of 0? It does. There's one of the factors. Now we've made it a smaller equation. We can take an x to the third and we'll end up with a binomial and a quadratic. Then can we factor the quadratic? So really cool stuff. Love it. Get excited about some of this math stuff when we get to do stuff that's a little unusual outside what we normally do, because we do a lot of just solving quadratics and stuff that's used so commonly. So, all right, guys, if I don't see you again, this is a B day Friday. So if I don't see you again this week, some of you may need to be here. Some of you may want to be here next class. But otherwise, if I don't see you, have a happy Thanksgiving. And then when we get back, we'll have to run like fire because we've got 2 weeks and then finals week when we get back. Short. Have a great holiday. See you Wednesday or next 2 weeks.